What if I told you some particles are passing through your body right now, unseen and unfelt? Welcome to the mysterious world of neutrinos. Neutrinos, elusive and enigmatic, are among the fundamental particles that shape our universe. Imagine an entity so stealthy it can slip through a light-year-thick wall of lead without a hitch. That's a neutrino for you. These particles, bereft of electric charge, with a mass almost negligible, interact very weakly with matter. This makes them incredibly hard to detect and study, earning them the title of ghost particles. They're the cosmic phantoms that permeate every corner of the universe, from the heart of the sun to the depths of the earth. Despite their shadowy presence, neutrinos play a critical role in the grand scheme of cosmic phenomena, from the nuclear fusion in stars to supernovae explosions. So, let's dive in, as we unravel the secrets of these ghost-like particles. Neutrinos are not your everyday particles. They are special, unique, and intriguing. They're like the undercover agents of the universe, nearly impossible to detect as they effortlessly pass through matter, barely interacting with anything. Let's dive into the fascinating world of these subatomic particles. Neutrinos are one of the fundamental particles that make up our universe. They belong to a family of particles known as leptons, which also includes electrons. One of the most striking properties of neutrinos is that they carry no electric charge. Unlike protons, which are positively charged, or electrons, which are negatively charged, neutrinos are neutral. This lack of charge is one reason why they interact so weakly with matter. They can literally pass through light years of lead without being deflected or absorbed. In addition to being chargeless, neutrinos are also incredibly light. In fact, for many years, scientists thought neutrinos were massless. However, we now know that they do have a tiny mass, although it's so small that it's still challenging to measure. Neutrinos are also elusive because they only interact via the weak nuclear force. This is one of the four fundamental forces of nature. But as the name suggests, it's much weaker than the others. This weak interaction allows neutrinos to pass through ordinary matter as if it wasn't there. Furthermore, neutrinos are produced in vast quantities in many natural processes. They are born in the hearts of stars during nuclear fusion, emitted during the decay of radioactive elements, and generated in the high-energy collisions of cosmic rays. Astonishingly, billions of these elusive particles are passing through your body every second, yet you don't feel a thing. And that's because they are so non-interactive that they pass right through without causing any disruption. So neutrinos are indeed very peculiar particles. They are neutral, incredibly light, and interact very weakly with other matter. And yet, despite their elusive nature, they play a crucial role in many of the universe's most fundamental processes. With these unique characteristics, neutrinos surely stand out in the particle crowd. Neutrinos come in different flavors, but don't get any ideas. They're not for tasting. Now, when we say flavors, we're not talking about vanilla, chocolate, or strawberry. In the world of particle physics, flavors refer to the three different types of neutrinos: electron neutrinos, muon neutrinos, and tau neutrinos. Each one of these flavors is associated with a different elementary particle. For instance, electron neutrinos pair up with electrons, muon neutrinos with muons, and tau neutrinos with tau particles. What's fascinating is that these neutrinos can oscillate or change from one flavor to another as they zip through space. It's like changing from vanilla to chocolate mid-scoop. This behavior of neutrinos is one of the many reasons they pose such a captivating puzzle to physicists across the globe. So remember, next time you think of flavors, don't forget the neutrinos. Detecting neutrinos is like trying to hear a whisper in a storm, but scientists have found ways. Think of neutrinos as the ultimate hide-and-seek champions of the universe. They're nearly massless and chargeless, allowing them to pass through matter almost undisturbed. This makes them incredibly difficult to detect, as they rarely interact with other particles. To catch these elusive neutrinos, scientists have to create conditions that favor such rare interactions. This is where neutrino observatories come into play. These aren't your typical observatories with telescopes pointed towards the sky. Instead, they are massive detectors buried deep underground, surrounded by rock or ice to shield them from cosmic rays and other particles that could interfere with the detection of neutrinos. One such observatory is the Super Kamiokande in Japan, a gigantic tank filled with 50,000 tons of ultra-pure water. It's nestled a kilometer beneath the mountains to escape the noise of the cosmic rays. When a neutrino interacts with the water, It creates a flash of light that is detected by thousands of sensitive light sensors lining the walls of the tank. Another fascinating experiment is the Ice Cube Neutrino Observatory at the South Pole. It uses a cubic kilometer of clear Antarctic ice as a neutrino detector. When a neutrino interacts with the ice, it releases a flash of blue light, which is then captured by optical sensors embedded within the ice. But why go through all this trouble? Well, neutrinos are an untapped source of cosmic information. They can provide insights into the inner workings of stars, supernovae, and even the early universe. They could also shed light on the dark matter mystery. In the quest to detect the undetectable, scientists are pushing the boundaries of human knowledge and technology. This is not just about finding a particle, it's about understanding the universe, one neutrino at a time. Though elusive, neutrinos can't escape the diligent eyes of science. From the heart of the sun to the depths of supernovae, neutrinos are universal travelers. The cosmos is teeming with these ghostly particles, and their journey across the universe offers a unique window into celestial phenomena. Let's start with our very own star, the sun. Deep within its fiery core, nuclear fusion processes produce neutrinos as byproducts. These solar neutrinos zip through the sun and across space, reaching our planet in vast quantities. By studying these sun-born neutrinos, we gain valuable insights into the sun's internal processes, its energy output, and even its future. Neutrinos also play a starring role in the spectacular death of stars, supernovae. When a massive star exhausts its nuclear fuel, it collapses under its own gravity, triggering a powerful explosion. This supernova event is not just a light show, it's also a neutrino bonanza. The energy from the collapse creates a burst of neutrinos which escape the star's core even before the explosion is visible. So, by detecting these neutrinos, we can get a heads up about a supernova before it lights up the sky. Taking a step back to look at the bigger cosmic picture, neutrinos also contribute to what we call the cosmic neutrino background. Just as the cosmic microwave background gives us a snapshot of the universe shortly after the Big Bang, the cosmic neutrino background offers clues about the universe's early moments. It's a kind of cosmic echo, a relic from the time when neutrinos decoupled from the rest of matter in the universe. But what about the mysterious dark matter that makes up about a quarter of the universe? Could neutrinos be a part of this enigma? Some theories suggest that a type of neutrino known as sterile neutrinos could be a dark matter candidate. While this is still very much a topic of ongoing research, it underscores the potential of neutrinos to shed light on the darkest corners of the cosmos. So, neutrinos are not just particles, they are cosmic messengers. Their journey from celestial bodies to our detectors here on Earth tells us stories about the universe that we wouldn't hear otherwise. Stay tuned as we delve deeper into these fascinating particles in the next scene. Welcome to the Ice Cube Neutrino Observatory, a giant telescope buried in the Antarctic ice. This remarkable facility is dedicated to one purpose: capturing and studying elusive neutrinos. Nestled deep within the frozen expanse, Ice Cube is a marvel of scientific endeavor, a testament to human curiosity. It's a place where the invisible becomes visible, where the untraceable is traced. Ice Cube's unique location and design allow it to detect high-energy neutrinos from cosmic sources like exploding stars, gamma-ray bursts, and cataclysmic phenomena involving black holes and neutron stars. It's like an under-ice sentinel, watching the universe's most energetic events unfold in neutrino form. The data gathered here has helped to advance our understanding of neutrino properties, their role in the universe, and the cosmic events that produce them. It's not just a telescope, it's a gateway to understanding the universe's most profound mysteries. In the ice-cold depths, Ice Cube is hot on the trail of neutrinos. The study of neutrinos is not just about understanding these particles, it's about understanding our universe. As we delve deeper into the realm of neutrinos, we find ourselves entangled in the fundamental questions about the nature of matter, the universe, and the fundamental forces. Neutrinos, with their elusive nature and unique properties, offer a unique perspective to probe these profound questions. For instance, the phenomenon of neutrino oscillations, where neutrinos change their flavor mid-flight, challenges our understanding of quantum mechanics. It hints at the existence of a world beyond the standard model of particle physics, potentially leading us towards a grand unified theory. Moreover, neutrinos provide us with a unique window into the cosmos. They can traverse vast intergalactic distances unimpeded, carrying information about cosmic events that other particles can't. They might even help us uncover the mysteries of dark matter, one of the most perplexing puzzles of cosmology. Beyond their role in fundamental research, neutrinos also have potential practical applications. For example, they could be used in medical imaging, providing a non-invasive way to examine the human body. In the realm of industry, neutrinos could potentially be used for communication or remote sensing, thanks to their ability to pass through virtually anything. In the field of energy, there's also the tantalizing possibility of neutrino-based energy generation. While it's purely theoretical at this point, some scientists envision a future where we could harness the power of neutrinos, the most abundant particle in the universe, to generate clean, renewable energy. So as we continue to study neutrinos, we're not just learning about these ghostly particles, we're also gaining insights into the fundamental laws of nature, the origins and structure of our universe, and potentially even discovering new technologies that could change our world. Neutrinos might be small, but they hold big promises for our future. Neutrinos, the elusive yet omnipresent particles, have taken us on quite a journey. We've explored their fundamental properties, their distinct types, and how they oscillate between these varieties as they traverse the cosmos. We've delved into their role in the standard model of particle physics, and the challenges we face when attempting to detect them. From the fiery heart of the sun to the explosive force of supernovae, neutrinos play a crucial role in cosmic events. We've discussed the potential link between neutrinos and the enigmatic dark matter, as well as their contribution to the large-scale structure of the universe, and we've highlighted how facilities like the IceCube Neutrino Observatory are pushing the boundaries of our understanding with their groundbreaking research. As we continue to unlock their secrets, who knows what neutrinos will reveal about our universe? Thank you for joining us on this journey, and remember, the universe is full of mysteries waiting to be discovered.